to talk about capacity tuning changes that we've been discussing. Brian, Leif, myself, and a few of us, Vijay, on Slack. It's a very short talk. Leif wanted to piggyback half of this session as well, so I'll try to wrap it up quickly.
Not half, maybe 5 minutes at the most.
Sure. So basically wanted to just go over what we have today for capacity tuning on ATS and how we want to evolve it, or what are the shortcomings with that we want to address. This came out mainly because we were tuning our keep alive timeouts, and there was a back and forth. So we currently have our keep alive timeout set in prod at, I think, a few minutes, like 15 minutes or so. There was a requirement from some of our application teams to make that longer. And we were debating whether that means it cuts down the resources or it has impact on the capacity. And then there was a bit of back and forth. Then I talked to Leif, and then we said, yeah, this is very hard to get right. Like, you don't know what the right keep alive timeout should be, depending on where the clients are and their pattern of activity. Maybe 15 minutes is too high, or sometimes it's too low, and we really don't want to be tuning that value. So the alternative is where so we then talked about how to make this make dependency on keep alive timeout lesser and lesser. That's how this idea has come out. I mean, this has been in talks for a while, sort of just revived it. So to give some background, these are the capabilities that we have today. There's an overall connection limit, which is proxy, config, net, connections, throttle. And this includes everything. It includes all the inbound client connections, outbound connections, and your R limit, and everything comes under this. This is basically the total open file descriptors. This usually is set super high because after you hit this limit, it starts throttling. So we, for example, in our production, we set it to like 300K, absurd number, which to be honest, we won't ever be able to sustain if they're all active. Then there is the max outbound connections. This is the connections that ATS makes to origins. There's a cap on the total connections per ATS. Then there are the transaction and connection timeouts. There are inactivity, active timeouts. These are typically to sort of make sure that there are no runaway connections, or there are no DOS attacks by malicious clients, or a network slow post sort of thing. Then there is also connection limits per origin, and this is more of ensuring that certain service going bad won't affect the rest of the services. It provides some sort of resiliency against service failures and latency spikes. So these are the features we have today. Here is the summary of their advantages and disadvantages. So overall connection limit, it works fairly well for HTTP1 traffic. You still have to set it very high, but at least there is no there's no factor of multiplication. Request is at most, connection is at most serving one request at a time. So your connections are roughly equal to the number of requests. Active connections are active requests. But the con obviously is with HTTP2, it changes the game entirely. Like a single connection can do, the way we have it set, I think our default is 100 in ATS. So a single connection could mean 100 requests. And that has a huge impact on the capacity, because request would involve your network, your CPU, basically all the resources that are important. So that's the sort of con for it. The connection transaction timeouts, they're good to protect against runaway transactions, leaks, or make sure that your resource utilization is efficient. But then they need to be tuned really carefully to make sure that you cover all the cases. And they also need to be tuned. You cannot set them too high. If you set them too high, then you're cutting down the capacity. But then that means that you could have use cases such as upload or long poll that you may want to serve. which will require higher timeouts, and there is a sort of chicken or egg situation in that. Then the origin connection limits, again, is good to protect against individual service failures or latency spikes. But the biggest problem that we've noticed with this is that it happens a bit too late. You've done half of your request work already. If it's a post request, for example, and if it's a gigantic upload, you've already and if you have buffering enabled, for example, which we do, you sort of got all the body, and then you go to the remap stage and see, oh, this has exceeded the connection limit, let me throttle it. Or if you have plugins running before remap and they're doing a bunch of activity, they're doing a lot of work, and you spent all of that work only to throw away that request at the remap stage. So it's while it's great, it's a little late in the game. We would ideally like to, if you want to throttle a request, the sooner the better.
Yeah, actually, we use that much more for origin protection rather than ATS protection, in that we've actually avoided outages because of these limits. They would keep the upstream running rather than
well, and yeah,
falling over.
You're using the per server connection.
That's true. Yeah, I should say, agreed. Yeah, I should say that that's actually a pro of origin connection. It also protects the origins. But I'm talking in terms of ATS's own resiliency in this talk. But yeah, you're right, Alan. This is actually to protect the origins as well. Yeah, it does protect the origin, but you could have impact on ATS by doing all that work. Even when
it moves a burden from the upstream to ATS essentially.
Exactly. Yeah, that's correct. Yeah. So this is basically a high-level summary of what we have and like pros and cons. So then we started talking about how to make this or how to improve this to sort of address some of these gaps. So at a high level, we are looking at maximizing the throughput based on CPU, memory, network bandwidth. If you use active connection limits, it works fairly well for HTTP1, but HTTP2 has that multiplexing problem. So the alternative is to use max requests, where in HTTP2 you consider a stream as a request, which we already do anyway. So that's basically what the concurrency limiter is, what we're talking about. So you basically, instead of using max active connections, use a max active request as the limiter, and you detect the cap at the entry point and throttle the request, basically. It also helps in reducing the dependency on timeout configs, because you could now approximate the your available resources and see how many requests you can serve. If you come up with a number that gives an average resource utilization per request, a factor including all the CPU, memory, and network bandwidth that you need, then you could actually set this max active request accordingly. Obviously, this needs some tuning, but this addresses the gap with connections limiting that we have right now. And keep alive timeouts at that point sort of becomes almost not important. You could set it as high as you want, simply because you already dedicated that much memory for idle connections. You sort of divide your total memory into workload and idle connections, because idle connections really don't do anything other than just staying in memory. So in that memory, you could set as high as you want. And the way we have it working in ATS, Brian did this work, is to you basically kick out the as your keep alive queue is getting longer and reaches its cap, you kick out the oldest connection first. So it sort of automatically adjusts itself. Yeah. So you solve that problem of hard to get right timeout values. Yeah, and so the proposed changes are, we will change max active connections to max requests in. We don't have the functionality for this yet. We still only do the max active connections at this point. But the plan is to change the config now so that we can add that functionality as an improvement rather than breaking compatibility. And basically it tracks the max number of in-flight requests or concurrency. The server max.
So for HTTP2 then, for HTTP1, this will be identical to connection limit.
That's correct.
But for HTTP2, Is it expected that you get a stream denial when they send a open stream request? How does that going to work exactly?
That's right. Yeah. So yeah, that's actually an open question. Yeah, I'm thinking of doing that as so. I guess we could. This is sort of like a design decision. When you reach the cap, do you want to close the connection or just want to send a go away to that stream? Sorry, go away actually closes the connection, right? We do you want to deny the stream or do a go away? I think either way should be fine. We probably should just refuse that stream. Yeah. I think that hasn't been decided one way or another yet, Alan. Right now, what happens is the connection is closed, even in HP2. If you hit the connection limit, but connection limit is sort of ineffective with HP2 because of the multiplexing problem.
It'd be interesting to see how clients deal with a rejected stream that you keep the session open. So
yeah, so we have had some experience with that. So we are doing this this whole concurrency using a plugin right now. The plan here is to make it part of the core, which makes obviously more sense. With the plugin, whenever we decline the stream without actually closing the connection, we, at least for our clients, we see a retry storm. It basically keeps coming back so fast and so, because it's 503 with almost no work, right? You're returning within a,
try again.
Exactly, and it comes back so fast. And it's also partly a broken retry implementation on the clients, which we're improving. But I think this is sort of common across most clients. I've also seen this behavior in a different company before. So so if, and especially because it's HP2, the problem is that that request comes back to the same box. It doesn't even get spread out. So you see these patterns of like super spiky. As soon as you throttle with HP2, you see a big spike because they keep coming back viciously. So what I've done is added for our throttling, we added a configurable connection close for HP2, and we rolled that out. This is just to keep the clients quiet until we fix the retry behavior. But yeah, I guess we could do something similar with ATS core as well, that we make the connection close behavior as a configurable option.
You can do an exponential back off and how fast you send the stream deny back.
They are supposed to back off, but
well, I'm saying you could, right? ATS could.
You could sit on it a bit, yeah.
I mean, you could have a status in H2 to say, well, I hit the limit and I sent everything, and then okay, so next, if I'm still hitting the limit without getting an open stream, I up the time before I respond until I get a stream through, and then I reset the time.
That is true. Yeah. So that's another option. We could add a small delay when rejecting the rejecting the stream or connection. Very small delay, and that delay increasingly.
That's going to be a bit tricky to implement.
So in the H2 protocol, there is the concurrence limit, which we noted is 100 by default.
Yeah.
Is that something that we could change as we go? Can we send a settings update saying, oh, hey, I'm feeling poorly, my max is now 50?
Sure, I think we can do that, but at the levels of QPS we're talking about where this becomes active, that may be a little, I guess we have to experiment, but that may not be sufficient to ensure that we recover. We also need some big hammer besides that.
Yeah, it would be less immediate, but it might be if you have a trend where you're overloaded, that might, the clients would probably understand that a little better.
Right. Yes. I think we could do that as a tier way, like at certain level we could start using the max concurrent stream, and then the next level is to big hammer, basically reject it. Something like that.
You can combine that with the backup too to say, okay, well, if I said get a deny because I hit the limit, I bump them down 5 or 10 max connections. If they send it back before they get a valid stream, I bump it down another 5 or 10. I keep bumping them down as long as they keep pounding on me.
Sure. Yeah, that sounds good. The good thing is all these options that you're suggesting, they're orthogonal. We could actually literally do them independently. The big hammer can go first, and then we can start adding at a lower level, do the tuning of max concurrent streams and also the delay. These are sort of steps in the where you reach the max level, and they're all orthogonal.
We should probably move on though. I don't think you want to do all the full design here in the meeting. Sorry.
Yeah.
Oh yeah, that's basically. I think we sort of talked about it. Change max active to max requests. The server max connections. There's really no change to it at this point in terms of functional aspects because we're not supporting HTTP2 outbound. But just to keep it consistent, we would just rename it as max connections out. And this includes both active and idle. This is sort of slightly different for server connections as opposed to the concurrency part. Then max connections in, we will continue to have this because this is like your bigger limit for all the FTs open in the process. The connections throttle, I think the desire is for us to kill this eventually. This should become the max in and max out. And this should just go away. Yeah, that's the proposal. Then the open points, I think we sort of already touched. What status code should be used? I guess 503 is an option, or maybe 429, or I think, or maybe make it configurable. HP1, we could send a connection close header if we want to close the connection. For HP2, we could send go away or refuse the stream. There is also the sort of related aspect of requests happening through your internal requests, your plugin initiated requests, which for some use cases are pretty significant, especially for us. We have a lot of sideways calls that we make. Should we make that as part of the same limit, or should that be treated separately? I mean, they are adding CPU workload at least for sure. Network, not so much because they're just locally originating. But yeah, it's something to discuss. And
I put it in the same. I mean, you control those, you can do things.
Yeah, for sure. Yeah, I think that makes sense. Just keep it as one part. I mean, it sort of becomes some factor anyway. Like maybe 2 requests is 1 request, or other way around. 1 request is 2 requests. Or something. Yeah, that's all I have. Any other comments or anything?
So currently, when you hit these limits, is it sending back 503?
Currently, we close the connection. We just actually do a socket close.
Okay.
Yeah, we're not even sending a 503. The proposal or the thing that we can talk about is, should we send a 503? It would be more graceful.
Yeah.
But it would be more work. It's not as simple as what we are doing right now.
Yeah.
It would involve starting the state machine, send a request, send a response. Stuff like that.
Yeah. I think it depends on how overloaded you are. I think we need to do like tiers of overload.
Right. Yeah, that's true. Yeah, I think this also can be totally a tune-up, like a tier level thing. Like at some stage we do 503, and even worse, then we basically just do a TCP disconnect. Yep. TCP disconnect is the easiest and sort of quickest way of getting out of the overload for us.
Yep.
Yeah, that's all I have. I think Leif, it's all yours now.
All right.
Yeah, so I had it's not quite exactly related, but it's similar related. It's something that came up within Apple where we have a requirement now for something that we call session pre-warming or connection pre-warming. The way it works today, right, we have session pools for origin connections, and that's essentially reusing sessions that have been created on demand for later use. What we want is essentially create connections before there is demand. So you would have a pool of, say, configurable minimum of 10 connections to an origin, such that when a client comes in, and this would be for the YCPI use case typically, right? For the Verizon Yahoo people, where a client comes in, makes a request, and instead of having to wait for the handshake between the edge node and the origin, we have a session just sitting there waiting, already handshaken, and it can instantly just kick off the request to the origin. So our sort of discussion topic here is, A, what do people think about this? Is this a good idea or not? Should we do this? And B, who else would be interested in working with us on this?
There is the minimum number of connections setting.
Yeah, but that's after 2 hours of looking at code together with Alan. What that one does is essentially saying when a connection comes back
Yep.
from being used,
Yep.
it won't throw it away. It won't throw connections away that are keep alive to go below the minimum settings. So it doesn't pre-warm anything, but it assures that you don't too aggressively kill keep alive connections to the origin.
Yep.
Well, the question is where the code would be to initiate that logic.
Well, so I haven't looked. I mean, I was looking at that, but you remember I asked about that setting, Alan. We were going through the code. So I would need to go look some more now that if we decide to do this. But essentially, there has to be a way where we would kick off a connection right today. Where you have nothing in the keep alive pool. We kick off a new connection, obviously. Mm-hmm. So somewhere around that area, there should be a check to make sure that that pool doesn't go below the configured number, say 10 or whatever. Meaning if taking a connection out of the session pool puts you under 9 or 10 or whatever you set the setting to, then kick off creating another one in the background.
So this count would be per origin, or?
Right, per origin, sort of as a origin name, right? It could be, it could be 50 origins behind that name, but for that name.
Well, we'd probably attach it to the current contract data, so you'd use that kind of matching.
Exactly.
So, like a long time back, we have something called a prefetch. Isn't this somewhat in a similar way as that?
The prefetch is more of a.
I think we retired the prefetch completely.
Yeah, we retired the prefetch concept, but
this is fuzz.
It was essentially saying when you fetch an HTML page, look at that page and prefetch the JPEGs and the CSS and JSON and that sort of stuff off of that page. That sort of stuff.
So, are you thinking this would be a plugin or an external process?
I think it would be difficult to do in a plugin today without changing APIs. So
essentially,
you really just need a metric to know how many connections you have to origins.
No. So what you have to do.
We already have those.
We already have metrics for this. That's the thing, right? We already know, and we already also have limits per origin, right? We can say do no more than 100 connection to news.yahoo.com, right?
We also have a floor. We also have min origin connections, and what you are proposing is to make sure that the floor is always maintained. Is it?
Well, so one option would be that the setting that we have today only deals with keep alive, right? So the min setting to origin only deals with keep alive. Make sure that the keep alive pool doesn't go below that.
Right.
You could just hijack that setting and say, this actually really means it should be 10, regardless if they will keep alive or whatever, right? So at any given time, it's always 10, or try to be 10. It can be a race here, right, between.
Yeah. So what you want to do is, anytime if you have a pool and it's got connections in it, one of those connections goes down to your upstream server, and you take it out of the pool because it's dead. You don't have a choice about that. It's dead.
Right.
At that point, I guess what Leif is saying, you would say, oh, wow, I'm down to 8 sessions in the pool for this guy. Yep. I better fire off 2 more connections.
Yep, and put them right back into the pool.
Yeah.
And the max already is overwritable, so the min would also be overwritable.
So that would be one idea to use.
Min is already overridable, but I'm a little confused. It doesn't go below min today once it crosses that. The only problem is if you never got to the min, you are below that. But once you got to the min, even if you take them as active, they are never released. They just go back to the...
For example, what could happen, for example, today is that they do timeout, right? And they get removed from the keep alive gets cleaned out. I mean, they can go idle or whatever.
Yeah, Sudhir, if the upstream closes it, you have to take it out of the pool. You don't have a choice because it's dead.
True. That's true. Those are the only cases that the connection is actually close to upstream.
But it's also only assuming that you actually end up being net positive at some
point. Well, and also this is like kind of having spares. Well, and also this is like kind of having spares, right? Which is different.
Right. Well, so what Sudhir is saying, which is right, is that if at some point you get over 10, then it tries to make sure that you don't prune more than leaving 10, right? But let's say on the steady state that you have nothing in the pool. You used all the ones that are in the pool. Until those come back, you have nothing that's pre-warmed. So if there's constant pressure on this on the sessions, then you never get to be ahead again until the pressure gets reduced, such that you can start building up the pool again. Whereas what I'm saying is that no matter what you do, regardless if there's pressure or not, you will always try to have 10 connections in the pool.
Leif, do your origins support TFO or TLS 1.3?
Some do, some don't.
Okay. I'm just curious because I mean you could just solve it at a different layer.
Yeah, no, I think this is reasonable. Unfortunately, I don't see where I'd get time to help you out with it because it sounds kind of cool. But
I think what Leif is asking for is different than minimum number of connections. He wants X number of free connections.
Yeah.
At least X
right.
connections.
Yes, he wants the pool size to be that. The standard database pooling stuff, right?
I mean, another option rather than piggybacking on this existing setting, which has issues on its own, but another one would be to sort of a more intelligent low watermark, high watermark settings where you say, try to stay above the low watermark at any given time, and you're allowed to go up to the high watermark on these settings, right? And then try to adjust how aggressive you create new connections based on those two settings and try to be in between those two. That would be probably even better because that way you can deal better with, because 10 might be a good number most of the time, except for the one case when you get the Michael Jackson death, right? When you get like a tremendous amount of traffic in a short amount of time, then that 10 could easily be, I mean, you could exhaust those 10 sessions in the pool quicker than you can create new ones.
Yeah.
So being able to adjust this sort of pool size based on increase and decrease in pressure could also be, I guess, a little more complicated though, but could also be a fun, interesting project.
Yeah, I'm just wondering that those whatever minimum number of extra idle connections that you're thinking of keeping will always be idle. With the way you're design or proposing the design, they'll basically remain idle all the time.
Right.
Is that really? Yeah, I guess it's a trade-off that it helps when there's a sudden influx of requests, but most of the times they just remain idle. They're not used at all and sitting there.
Yeah, well, it's your classic performance resource trade-off, right?
Right.
You get much faster performance, but then you're spending all those resources on connections in some sense you never use, if you see what I mean.
Yeah.
So, you know, well,
it's a buffer essentially, right? It's sort of make sure that the buffer doesn't go down to 0.
Right. But there's also, I mean, there's some caveat here is that these keep alive connections, sometimes when you try to reuse them, the server side has already closed them. And if it's been too old and you end up using it and we don't even have good ways of retrying in some cases, it actually hurts service.
It might be that we also need to make changes here to address that, right? Such that if you get a connection that's for some reason is noticed to be disconnected or closed, go back to the pool and pick another one.
Right. Yeah.
I mean, that seems like a something we should do regardless, honestly, of this.
Right. Yeah.
Well, that runs into the idempotent thing that Susan mentioned earlier, in that what happens is you get the connection out of the pool, you write the request to it, and then you get the close, and you don't know when exactly that closed.
Yeah.
Right.
That's true.
You might be able to do better detection in there, but this is it's starting to come back to this. Why this was done. I think that was one of the reasons, is that it was hard to know this anyway.
The other thing that we also want to do here, just to hijack even further, is that, so we've been looking at the stuff that Susan and her team have been working on for, I think Alan was involved too, for essentially TLS, or not TLS, TCP proxying, right? You're setting up tunnels for TCP, and we would like to have session pools for those as well.
Okay. Yeah.
And the same concept, that they can't be reused, in our case at least, and probably not your case either, but same reason, right? If we can have a session pool here and we can pre-warn that session pool, then when someone comes into and asks for this TCP proxy tunneling, they just get one that's already established to the next hop.
Yeah, basically you pipelined it. Yeah.
Yeah. So there's sort of two similar but slightly different projects here that we want to do, and then maybe the third one would be to look into, make sure and I talked to Sudhir about this afterwards, but maybe we should look into making sure that when you do get a crappy session out of the session pool, to see what we can do to improve the logic here to try to pick another one rather than giving an error to the client.
Yeah.
Yes.
It seems like if we did H2 outbound, some of the issues will go away.
Yeah.
Yeah, a little bit. Yeah.
Well, you still have some connections.
Yeah.
You still want, but it'd be a lot fewer to manage.
And also, I mean, and presumably you can do, say, 100 streams on a connection, right? You only need to have a small number of connections to be able to do thousands and thousands of clients.
Right.
Well, in that case, what you're going to want to say is, I want n spare streams. So I know that if I get a request in, there's a spare stream on some outbound that I can use instantly.
Well, you're also going to need to set a ratio between how many requests or how many connections and how many streams and all that kind of stuff, and it's going to have to figure all that out. So
yeah,
if it's used up all of its streams, it needs to create a new connection, all that. Yeah.
Yeah, we've been through that before. It's a subtle issue of exactly how you control your streams and how you do sharing among cross connections versus streams, right? Can I have one client come in with 5 streams and put up 5 outbound ones on different streams there, or do they have to be the same? It's going to take some
configuration.
Well, so I was going to say serious thought about how this is supposed to work.
I mean, because
it's not something you're going to whip out in 5 minutes.
The next step is I'll write this down, and sounds like we have sort of 3 projects here. I'll probably file some issues on each one of them as well, and we can see who would be interested in at least participating in design and scope of this, and see how we go move along with the implementations. So just no one sees any sort of reason not to do this, I hope.
Other than effort, no.
So who here uses global shared sessions versus per thread?
So we use global. We used to use per thread in the past. We switched to global.
Okay. Leif, what do you guys use?
Who?
You? What do you use global or per thread on shared sessions?
We use the per thread one.
Okay.
Yeah, we probably need to look at some of the lock contention for the global pool sessions.
Yeah.
So that's.
So what do you use, Susan? Global.
We use global.
Okay.
We use global, yeah. And there's lock contention issues, obviously, with global, and we are very, hesitant to do anything smart. So if it's like, oh, we don't get the lock, we're out of there.
But why did you switch to global, Sudhir? Did you have a reason for it?
Yeah, we had, so we were doing this TLS migration across our data center, across all the services. With that, we ran into issues where the higher the connections, there were sorts of CPU issues. We wanted to make the reuse more efficient. I mean, in theory, it should be the same, I guess, but yeah, with global, we saw a big reduction in number of connections.
I think it depends on your distribution of origins, because one of our clients, we just fixed their problem by moving them to thread pools because they had a very few number of origins, and they had much better reuse because they didn't have the lock contention issue by going with thread pools. But for us, we have a lot of origins, and if we go threads, our number of connections go away.
That's true. Yeah, if your average number of origin connections is less than your number of threads, then you're going to have a lot of excess connections to that upstream, and the upstream complains you're overloading me.
Right.
It becomes a low average here, right? If you're too low, then you.
If on average you're going to have 2 or 3 connections upstream per thread, then you're better off with thread pools because you're not. Right. You see the number of excess connections drops off.
Right.
To 0.
There's also another factor there is that we still use the old default for a number of threads, the 1.5 factor, of course. So we are running about 50 threads per box. So that also is adding to the misery. I'm planning to change that to 1 with ATS 9. That should help.
Should we change the default for that?
I think we did. Is the default still 1.5?
I think we should change it to 1 at
least.
We should, yeah.
because I think now with so many cores, we're getting a lot more lock contention and stuff.
Correct. Yeah.
We should do that for 9 though. Whoever wants to do that, put that in for 9 so we.
I got it.
Yeah. I'm okay with that too.
Okay.
Yeah, it's still at 1.5.
So do we want